Now in this video lecture we will go through inductive effect. Right. Inductive effect will again help us to understand some properties of organic molecules, right, which are related to the reactivity, right, reactivity of organic molecules. So inductive effect will help us to understand the reactivity of organic molecules in while looking into the mechanism of organic reactions, right. So inductive effect, right, let's understand it first. Suppose this is your methane group, right, this is your neutral molecule, right. Now for methane molecule to undergo a chemical reaction, right, or for methane molecule to be attacked by a reagent, right, because a chemical reaction will occur only when this molecule would be attacked by a reagent, right. Now since this molecule is neutral and we know that reagents are charged, positively charged or negatively charged, right. So these reagents will only attack the organic molecule if the organic molecule has positive or negative charge, right, or if it has positive or negative centers, right. So organic molecules, these reagents, right, these reagents will attack organic molecules if organic molecules have positive and negative centers, right. Now let's see how inductive effect will help us to make this molecule reactive, right, how it will make these reagents to attack the organic molecule, right. Now why this molecule is neutral, first thing is why this molecule is neutral, because, or the other way we can say why we don't have any positive or negative center in methane molecule, right. It's because the electronegativity of carbon and hydrogen is almost same, 2.5 and 2.1, right. Electronegativity, what is electronegativity? It is the ability of an atom to attract the shared pair of electron towards itself, right, in the bond. If this is a bond, right, we have 4 bonds, CH bonds, right, and the electrons that make up this bond, right, this is what? This is a sigma bond, right. If you go as per chemical bonding, this is a sigma bond, and the electrons that make this bond are sigma electrons, right. From now onwards we'll use the term sigma electrons and pi electrons. And what are pi electrons? We know that in alkenes, right, that have a double bond between carbon and between carbon atoms, they have double bond, and one of the bond is a pi bond, right. So electrons that form the pi bond are pi electrons, right. So now here this CH bond consists of sigma electrons, right. Now since the electronegativity difference is very less between carbon and hydrogen, the sigma electron pair or the electron pair forming this bond is almost in the center, right. So no charge on carbon or hydrogen. Now let's do one thing, let's replace one hydrogen atom with a chlorine atom, right. We know that electronegativity of chlorine is high compared to carbon, right. So what it will do is it will attract the shared pair of electron towards itself. This sigma electron would be displaced more towards chlorine atom due to the high electronegativity of chlorine, right. So this sigma electron would be displaced towards chlorine atom because of high electronegativity of chlorine atom, thereby giving a slight negative charge on chlorine atom, right. Now since this electron pair has moved far away from carbon atom, right, and we know that electron pair is what? This is negative charge, right? So if negative charge is moving away towards chlorine atom, it will give negative charge to chlorine atom, and since negative charge is moving away from carbon, carbon will get equal positive charge, right? So now you can see introduction of chlorine, right, has made this methane molecule reactive. How? Now if you have OH or H, now this OH can easily attack the carbon atom, because carbon atom now has positive charge, right? Due to positive center in this molecule of methyl chloride, this molecule is now more reactive compared to methane, which was not reactive earlier, right? Now due to this positive charge, this reagent can easily attack carbon atom. Now this has become a reactive molecule, right? Similarly, if suppose I have a long chain of carbon atom, right? Now if I introduce chlorine in place of hydrogen here, now we know that chlorine will displace the electron pair towards itself, right, like this, right? So now since electron pair would be displaced towards chlorine, chlorine will get negative charge, this carbon will get positive charge. Now you have sigma electrons here also between, okay, if I number these carbon 1, 2, 3, right? Now the sigma electron between C1 and C2, right, the sigma electron would be displaced more towards carbon atom C1. Why? Because carbon has positive charge. Now this positive charge will displace the negatively charged electron towards itself, right? Right. So this positively charged, and thereby making this carbon more negative. When this electron pair would be shifted away towards C1, away from C2, this carbon will also acquire a positive charge. Similarly, now you have positive charge on this carbon, you have electron pair sigma electrons between C2 and C3, so this electron would be little displaced towards C2, right, thereby giving a positive charge to C3, right? This positive charge, now why all these carbon why all these carbon atoms have acquired positive charges? Due to the presence of electronegative atom at the end of this carbon chain, right? This is a chain of carbon atoms. If I replace hydrogen with chlorine atom, which is highly electronegative, it will displace electron towards itself, making this carbon positively charged. Now this positively charged carbon will displace electron little towards itself, making this carbon positively charged. Now this will also displace electron towards itself, making this carbon positively charged, right? And this positive charge will decrease towards this direction. In this direction, this positive charge is decreasing, right? And this effect will almost diminish or will go off after third carbon atom. After third carbon atom, the positivity of carbon is almost gone. So on fourth carbon atom, there would be very weak or no positive charge on the fourth carbon atom, right? So this is your inductive effect, right? Due to inductive effect, we introduce polarities in organic molecules, right? Now let's introduce some other group. Instead of chlorine, let's introduce some other group that is electron repelling, right, or one that can donate electrons, right? Let's say we introduce a methyl group, right, or let's introduce some other group. Let's take general first, right? Let's introduce a group Y, right, in this carbon chain, and the electronegativity of this group Y is less compared to carbon. Here electronegativity was of chlorine was more than this carbon atom. Here electronegativity of Y group is less than carbon atom. So what it will do is, based on electronegativity difference, since carbon has higher electronegativity than Y, so what it will do is it will displace sigma electron towards itself like this. It will displace sigma electron towards itself, giving it a positive charge, and here it will get a negative charge. Carbon will get a negative charge because of higher electronegativity. Because of higher electronegativity, it will displace the electron, the sigma electrons of this bond towards itself. When electrons would come close to carbon atom, this carbon atom, it will acquire a negative charge. Now it has a negative charge. Here you have sigma electrons. Now these sigma electrons, it will, due to this negative charge on this carbon atom, it will repel these electron pair. This electron pair would be repelled by this carbon atom, thereby displacing it more towards this carbon atom, right, giving it a negative charge, right. Similarly, you have negative charge here. Now this negative carbon will again repel this electron pair towards this carbon atom, thereby giving a negative charge, right. And this negative charge will keep decreasing as you move towards this direction, right. And remember, this has more electronegativity than carbon, right, and this one has, and this Y has less electronegativity than carbon, right. I hope this is clear. Right. So this is your inductive effect, right, that will introduce polarities in your organic molecule, right. So where we have less electronegative atom, right, in this case, this is your plus I effect. We call it as plus I effect, where carbon atom will acquire a negative charge, right, and we have atom attached to carbon atom that has less electronegativity than carbon atom, right. Now this is your, this one is your minus I effect, right. This is your minus I effect, where this chlorine atom will attract the shared pair of electron towards itself, right, thereby making it negatively charged, and this is your positively charged, right. Carbon has become positive charge here. Carbon has acquired positive charge here because of high electronegativity of chlorine atom, right, and this is your minus I effect, right, and this entire thing is your inductive effect, due to which we get positive and negative ends in the organic molecule, right. This inductive effect of chlorine and Y group has introduced positive and negative ends in the organic molecule, right. This is your inductive effect, and this happened, and why this has happened, why this molecule has acquired a positive and a negative charge, because of electronegativity difference, right, and we know electronegativity is the ability to attract the shared pair of electron towards itself, right. I hope this is clear. Now inductive effect, if you want to define it, the displacement of sigma electrons, right, along a saturated carbon chain. In this case, in inductive effect always takes place in saturated carbon atoms, in saturated carbon chain, right. Saturated carbon chain means the carbon chain that has only sigma, only single bonds, no double bonds or triple bonds, right. So the displacement of sigma electrons along a saturated carbon chain due to the presence of an electron withdrawing or electron repelling group at one end of the chain. Here we have electron withdrawing group, here we have electron repelling group, right, resulting in the development of partial positive and negative charges in the decreasing order of magnitude is called inductive effect. Decreasing order means towards this direction the positive or the negative charge is decreasing. As you move away from the electropositive or this group, right? As you move away from this hetero group, this is a different group, right? The charge will keep on diminishing or decreasing, right? Now let's quickly look into some of the applications of inductive effect, right? Let's look into some of the applications of inductive effect. Due to inductive effect, we say, let's look into the acidity of some acids, like chloroacetic acid, right? If we talk about the acidity of acetic acid and chloroacetic acid, right? Let's check that, right? Relative strength of acids, right? Relative strength of acids. Acidity of some acids, or we call it as relative strength. How inductive effect will help us to understand the relative strength of acids. We'll look into that. Okay, what is an acid? Acid is something that can release a proton, right? That can release a hydrogen ion in solution, right? So if I add water to acid, right, then that acid will liberate hydrogen ion, right? The more easily it will liberate hydrogen ion, the stronger is the acid, right? So we'll see how this inductive effect will help an acid to liberate the hydrogen ion more easily or with a difficulty, right? So effect of, we'll understand here the effect of I effect, that is inductive effect on acidity. Right. Now suppose the acid that I have is, right, any group, right, any group or atom which help in the release of proton from an acid increases the acid strength, right? We have discussed all this. So in case of, let's talk about carboxylic acid. In case of carboxylic acid, this is your carboxylic acid, right? When this proton, release of this proton, right, will make this acid more strong. More easily this proton can be lost in solution, stronger is the acid, right? Now let's see if I introduce some other group, right? If I introduce some other group that attracts this shared pair of electron towards itself, right? Suppose if I introduce Cl, we know Cl has higher electronegativity, like we introduced it here. So Cl will attract the shared pair of electron towards itself, right? It would be positive charge, right? And it will, since it's attracting the shared pair of electron towards itself, the electron pair will move away from the oxygen atom, right, making oxygen more positive, right, making oxygen more positive, right? Hence, due to oxygen becoming more positive, the release of hydrogen will become easier, right? So relative strength of some common acids would be if I take this acid, if I introduce say 2 chlorine atom, now this will also attract the shared pair of electrons, right? It will move the electron pair more, it will displace the electron pair away from oxygen atom, right? Now if I displace the electron pair more away from oxygen atom, it will acquire a positive charge, right? This oxygen atom will acquire a positive charge. We know the hydrogen proton is again it's a positively charged, right? So this proton will easily lose, or this proton will easily leave the rest of the molecule, right? The more easily this proton can leave, stronger is the acid, right? So if I have two chlorine group in this methyl group, right, which are electron attracting, making this oxygen more positive, or it will displace electrons more away from oxygen atom, right, and making the release of proton more easier, right? So introduction of a group or an atom that has higher electronegativity than carbon will make the acid more stronger, right? So we say, if I introduce, say, one more chlorine group here, then it will attract more electron. The electron attracting tendency will become more, right? So this oxygen will become more positive, right, thereby making the release of this proton more easier, right? So CCl3 COOH would be the stronger acid, right, whereas CCl2 HCOOH, right, is weaker than this. Then comes your CCl, right? Then you have CCl, let's write it like this, CH2Cl COOH, right, greater than CH3COOH. This is the weakest acid, right? Acetic acid is the weakest acid, whereas trichloroacetic acid is the strongest acid, right? Why is it strongest acid? Because it can attract the shared pair of electron towards itself, right, making the release of proton easier, right? Now let's look into the reactivity of alkyl halides, right? And this is your minus I effect. Due to minus I effect, the acidity has increased. Now suppose if I add some group here, right, that will release the proton, that will release the electron, or that will displace the electron towards the oxygen atom, right? If I take, say, any group Y, right, now this Y, this is electron releasing, or the other way we say is that Y has less electronegativity than carbon. So carbon will displace the shared pair of electron towards itself, making it negative, right? This will also be negative, and this electron would be displaced more towards oxygen, right? This will again become negative, right? So since oxygen has a negative charge, it will make the release of this proton difficult. The negative charge on oxygen atom will make the release of proton difficult, right? Thereby making this acid as a weaker acid. Now this is a weaker acid. So this is your plus I effect, right? So plus I effect, where you have an electron releasing or an atom that has lower electronegativity than carbon, right, will make this acid a weaker acid, because it will displace electron towards oxygen atom, thus making the release of proton difficult, right? So plus I effect will decrease acidity, minus I effect will increase acidity, right? And I've shown you the order. Now let's look into the reactivity of alkyl halides, right? Reactivity of alkyl halides, we have already seen here, the reactivity of alkyl halides will increase. The reactivity of methane is less as compared to this alkyl halide, right? Because if I introduce this halide, this chlorine group here, it will create positive and negative charge in the alkyl halide, right, making this alkyl halide more reactive. And now this reagent can easily attack this carbon atom, right? Now, if we talk about tertiary halides, tertiary, secondary and primary halides, right? If we take, let me just rub this off. Suppose we take this, right? These three are electron releasing groups. These methyl groups are electron releasing groups, right? So since these are electron releasing group, right, this is more reactive as compared to, this is your tertiary alkyl halide. This is again your, this is your secondary halide. This is your primary halide, right? Now, the inductive effect will explain the reactivity of these primary, secondary and tertiary alkyl halides, right? Secondary alkyl halides are more reactive than primary alkyl halides, right? Secondary alkyl halides are more reactive. You can see secondary alkyl halide, this is your secondary alkyl halide. It has two methyl groups which are electron releasing groups, right? And your secondary alkyl halides, as right. So secondary alkyl halides are more reactive than primary alkyl halides, and tertiary alkyl halides with three methyl groups are more reactive than secondary alkyl halides, right? As the methyl group enhances the minus I effect, right, of the halogen atom. So the minus I effect of halogen atom is enhanced due to the presence of these electron releasing groups, right? Here this halide ion, what it will do is it will attract the shared pair of electron towards itself. Now these are electron releasing, right? They are releasing electron towards this carbon atom, and what this alkyl halide is doing is it is displacing it more towards itself, right? Similarly, same thing is happening here also and here also, right? That is why we say that secondary alkyl halides are more reactive than your primary than your tertiary alkyl halides, right? Sorry, secondary alkyl halides are more reactive than primary alkyl halides, and your tertiary alkyl halides are more reactive than secondary alkyl halides. This is the order that I have made. So, right, this tertiary has maximum reactivity, then secondary, then you have primary. Why? Because the methyl groups, here you have three methyl groups that are electron releasing, that are helping the minus I effect of this halide ion, halide group, right? Here you have only two alkyl groups that are electron releasing, right? And here you have halide ion, right? So this is attracting the or displacing the electron towards itself. More number of electron releasing group will help the minus I effect of this X group, right? That will increase the reactivity. So in short, this is an electron attracting group or atom, right? Now this electron attracting group, you have seen how it has increased the reactivity of methane, right? How the reactivity in this alkyl halide has altogether increased when we introduced Cl group. So that effect of Cl group, due to which it has introduced positive and negative charge in this molecule, is increasing with the number of methyl groups. More is the number of methyl groups,